Welcome back to 8th grade science. So this should be the second time we are working through one of these videos on Edpuzzle. Maybe it's the third time, depending on which class you are. All right. So we should be getting into a rhythm. You know that when we do a problem, you are following along with me on the we do side. When I pause the video or the video pauses itself and asks you a question, that's on the right, on the you do side, okay? We're going to go through two problems today that are similar, and then we're going to do a third that I'm going to let you do completely on your own. I'm not going to model it for you, all right? The first one, I will model it for you. First question, how many valence electrons are in an atom that can be found in group 15 of the periodic table? Write your answer on the line below. I'm going to come peek at our graphic organizer. Group 15 is right here. You can always find it at the top. Sometimes my coloring might cover it up. If it does, look at your star periodic table rather than your graphic organizer, okay? Underneath here, I see that we are in group 15. A quick reminder, as you move across, you are increasing the number of valence electrons. So for instance, in the first group, you have 1. In the second group, you have 2. In this transition metal section, we put our frowny face. We don't count valence electrons in there because they can be variable or they can change. In group 13, we have 3. Group 14, we have 4. That's a bad 4. Group 14, we have 4. 15 is 5. 16, 6. 17, 7. And 18 has a full shell. It has 8. So this is pretty straightforward. I have a group 15 element. I come back to my packet. There are 5 valence electrons. Okay? You should do these same annotations on your graphic organizer so you can answer the next question. It should be really, really easy. Your question is asking you how many electrons, valence electrons, are found in group 18, the periodic table. All right, the video is going to pause. Good luck. Give it your best shot. All right, now that we are back, I'm really briefly going to go over this. Now I'm going to go back to the periodic table. We know group 18, 8 valence electrons. Group 15, 5 valence electrons. Group 17, 7. Group 16, 6. Group 15 is 5. The only difference is that 1 and 2 have 1 and 2 valence electrons, and then group 13 has 3, and group 14 has 4. It goes up into the teens, but that last digit will always tell you, okay? Next up, this is a star question. Number 46. A student is studying the ways different elements are similar to one another. Diagrams of atoms from 4 different elements are shown below. I know a couple of things about these diagrams. First, I know the outer shell, I want you to write this with me, is equal to VE minus, or valence electrons. The outer shell tells me how many valence electrons there are. The question says, which 2 atoms are of the same group in the periodic table? Please write with me, same group equals same number VE minus. I don't care what's on the inside, but I know that the same group has the same number of valence electrons. I'm going to count now the valence electrons in red, and as long as we find some of these atoms with the same numbers of valence electrons, we know they're in the same group. Atom 1 has 1, 2, do this with me, 3, 4, 5, 6 valence electrons. Atom 2 has 1, 2, 3 valence electrons for atom 2. So atoms 1 and 2 are not in the same group because they have different numbers of valence electrons. Right? Atom 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. And I'm going to add an extra annotation here that I want you to add. Write full shell. Number 8 is that magic number. The van is full. The bus is full. No more electrons can fit in there. If we add another electron, we need another shell. Finally, let's count atom 4. 1, 2, 3, 4, 5, 6. And I think I have found my answer. I'm going to use blue. There are 6 valence electrons in atom 1. 6 valence electrons in atom 2. In atom 4. Well, that tells me they're from the same group. So I have to scan, find the one that says 1 and 4. And there's my answer. All right. Remember, when we're looking for things from the same group, they have the same number of valence electrons. If they have the same number of valence electrons, they share similar properties of reactivity. okay? Similar properties of reactivity. Using the same picture from the right side, this is what you'll do next. Answer the following question. Examine the categories of reactivity below. Which option correctly identifies the atoms by their reactivity? This is a new word to us today, right? The word reactivity should be something that we're getting used to seeing. It is not a familiar concept to us, maybe, but it needs to become familiar. Reactivity means tendency to react with others. So reactivity can mean something like the tendency to explode or the tendency to give off heat. If something's really reactive, it's not hard to change it. It's not hard to change it. And you know something is reactive if it has space in valence. I want you to write this. Shell. If there's any space in that valence shell, if there's another seat in the van, you can have some sort of a reaction because another atom can come up next to it and give its electrons. They can pair up. When they pair up, they react. That tells us that 8 valence electrons in shell is, and I'm going to be really clear here with all these colors, not reactive. If there are 8 valence electrons in a shell, that means that the atom is not reactive because it is already full. There's nothing that can add to that shell. If nothing adds to it, it doesn't want to partner up with any other atom. It's fine the way it is. So when you're doing this question, think which of these has a full valence shell and what does that mean, okay? I'm going to give you a few seconds. Good luck. All right, now that we are back, we should have entered our answer into Edpuzzle. And what did it show us, all right? I see A and B, and I'm instantly going to think about why these are wrong. None of these atoms are reactive. That is incorrect. Remember, they are reactive if they have other than 8 valence electrons. There's 6 right here, there's 3 right here, and there's 6 right here. Those 3 are reactive. A is incorrect. All of these atoms are reactive. That's wrong, too, because we know atom 3 has its full valence shell. Not all of the atoms are reactive. Atom 3 isn't. And now that actually gives us our answer. So C says atoms 1, 2, and 4 are reactive. Atom 3 isn't. And D says atoms 1, 2, and 3 are reactive. Atom 4 isn't. We said atom 3 is not reactive. The correct answer here is C. Reactivity is tied to the number of valence electrons in the shell. Okay. Here's our final question, and I'm going to have you do this solo, and then I'll break it down, and that'll be the end of our video. Number 5, a researcher wants to experiment with an element that reacts like phosphorus, but has a greater atomic mass. Which element should the researcher select for the experiment? I'm going to give you steps to follow, and then you're going to complete this question. First step, find P, identify group number. So you need to find phosphorus. And because we're looking for an element that reacts like phosphorus, we're looking for an element with the same number of valence electrons, but a greater atomic mass. So you need to find the group number. After you find the group number, look down the column. Why are we looking down the column and not up the column? I'll give you a great example using a different atom. Why are we looking down the column? Let's look at beryllium, or let's look at magnesium and calcium. I'm going to circle them. Magnesium and calcium. These both have 2 valence electrons because they're in group 2. But as we go down, we notice an increasing atomic mass. It's really, really blurry, but the atomic mass of magnesium is about 24, and the atomic mass of calcium is about 40. So as you move down a group, the atomic mass increases. You see up here, beryllium's atomic mass is like 9. So going down a group increases the atomic mass. You need to go back to your note or your packet here. You need to find phosphorus, know what group it's in. Scoot down that group, down that column, until you find an answer. One of those 4 options, A, B, C, or D, will be down the group from phosphorus. All right? Video's going to pause. Good luck. All right, now that we are back, I'm going to transfer my answer options to the periodic table to make this easier. I have nitrogen, sulfur, arsenic, and silicon. Nitrogen, sulfur, arsenic, silicon. All right. So I need to find phosphorus. That was my first directive. Find phosphorus. I found phosphorus. Circled it in black. It's 15. It's in group 5, so I'm looking for something else with 5 valence electrons, but it has to have a greater atomic mass, okay? First option, I look at nitrogen. Nitrogen has 5 valence electrons, but I'm going to put a line through it. It is less atomic mass. It's up in the column, so it would not have a greater atomic mass. That's not what the researcher is looking for. Next up, sulfur. I find sulfur, and I see that that's in group 6. It does not have the same reactivity. The researcher is not looking for it. Get rid of sulfur. Find arsenic, and I think I have my winner. I see arsenic is in group 5, and it is below phosphorus. That is exactly what the researcher is looking for, because if it's below, it means it has a greater atomic mass. I can circle arsenic, okay? This is going to be the end of the video here. I want you, as the video ends, to fill out this extension question. Rewrite, because we already kind of wrote it, the thinking strategy you used to answer question number 5. How did you use your periodic table to find an atom with similar reactivity but a greater atomic mass? What does it mean to be similarly reactive but to have a different or greater atomic mass? That's what I want you to write one complete sentence answer to, okay? Great job. This is the end of this video.